going to start talking about chapter 21, which is all about chemical bonding. And in this chapter, we're going to be talking about the different types of bonds: ionic bonds, covalent bonds, and metallic bonds. And we'll be spending a lot of time talking about how you can look at the formula of a compound coming from either a covalent bond or an ionic bond and figuring out what the name of that compound is, or looking at the name of a compound, again coming from either an ionic bond or covalent bond, and coming up with the chemical formula for that. But before we get to that, let's go over a few basics here. So chemical bonding versus chemical bond. Chemical bonding is when you have two or more atoms that are joined together to make a new substance. And then the chemical bond is the interaction between the electrons that holds those atoms together. All right. Now, when atoms bond together, that happens because of the electrons. The electrons are where all the action is, and it's with the valence electrons that we are concerned with. All right, so we know valence electrons are the electrons in the outermost energy level, or the outermost shell. You're going to hear the term shell a lot in this chapter. Remember, shell and energy level, they're the same thing, basically. So the number of valence electrons determines what type of properties an atom has, and it also helps us understand what type of bonds the atoms are going to have. Of course, we know that the group or family that the element is in helps us determine how many valence electrons. And if an atom has less than 8 valence electrons, then those atoms are likely to form bonds. Whereas atoms that have 8 valence electrons, with the exception of helium, which has 2 valence electrons, but we consider them to have full outer energy levels or full outer shells, they're not really going to bond because they're already happy. They've already got those 8 electrons or 2 electrons in the outer energy level, and they're good to go. All right. So let's talk about bonds. We've got 3 types of bonds that we're going to look at. Now, there are several other types of bonds, but the ones we're going to be concerned with are ionic bonds, covalent bonds, and metallic bonds. And really, we're going to mostly focus on ionic and covalent bonds. Okay? So for ionic and covalent bonds, these bonds are going to take place because atoms are either going to share electrons or they're going to gain or lose electrons in the outermost energy level. All right? And as we said, full set of electrons for like say helium or some other elements is going to be 2 electrons, but most of the time we're going to be looking at a full set equaling 8 valence electrons, or 8 electrons in the outer energy level. All right, so let's talk about ionic bonds. All right, so ionic bonds occur when atoms either gain or lose electrons, and we end up with ions. And of course, we know ions are atoms that have a charge because there are either more electrons than protons or less electrons than protons. And that's why we call them ionic bonds. All right. And of course, we know the opposite charges are attracted to each other. And so we have positives being attracted to negatives. All right. And ionic bonds occur between metals and nonmetals. All right, you need to know that. Ionic bonds occur between metals and nonmetals. So the metals have positively charged ions, and the nonmetals have negatively charged ions. And those ions are going to be attracted to each other. All right, so before we start talking about the actual bonding process, let's talk about metals versus nonmetals. All right, so metals, we know they're on the left side of the periodic table. They tend to have fewer numbers of valence electrons. All right, and those ions that are formed with metal atoms are called cations. All right, so you need to know that, cations. All right, and we usually focus on the either alkali metals or the alkali earth metals, groups 1 and 2. But we'll also look at some metals that are in the transition metals. And what's important about the transition metals is they can have more than one charge. All right, so take iron for example. It can have either a positive or a +2 charge or a +3 charge. All right, so we'll get into that later when we start talking about the bonding process. Okay, when we write an ion, which we've gone over this before, remember the charge is a superscript, and remember if it is a +1 charge, we don't put a 1 there. The plus sign itself accounts for that 1. All right, and then you have +2, +3, so on and so forth. Okay, here's something else that's new. A charged atom, or the charge on an atom, is also called the atom's oxidation number. You need to know that as well, okay, the oxidation number. All right, so let's take a moment and look at oxidation numbers and how we know what the oxidation number is for an atom. All right, so let's just look at the periodic table. So remember, we have used the periodic table several times to figure out, say, the number of valence electrons an atom has, or how many energy levels an atom has. And so again, we could use the periodic table to figure out the number of valence the oxidation number of an atom. Okay, so we know that group 1 has 1 valence electron. So if it has 1 valence electron, that means it's going to lose that electron, and it's going to have a +1 charge. All right? So a +1 charge. Group 2 has 2 valence electrons, and so it's going to lose 2 electrons, and therefore it's going to have a +2 charge. All right? So I can already bet that you can see what's going to happen here with the pattern. So remember, the transition metals, they kind of follow some different rules, so we'll skip over that. So the boron group, group 13, has 3 valence electrons. So they're going to get rid of those 3 electrons, so they will have a +3 charge. Now, the carbon group is a little bit funky because they have 4 valence electrons, so we're kind of at that halfway point. So that means atoms in the carbon group can either have a +4 charge or they can have a -4 charge. It just depends on what element is being used here. So they can have either a +4 or a -4 charge. All right? Now let's move on. The nitrogen group is going to have 5 valence electrons. So now that we're past 4, we're up to 5, it's actually easier for the elements in the nitrogen group to actually gain electrons than it is to lose electrons. So they are going to tend to gain electrons, so we're going to have a negative charge. So they're going to want to gain 3 electrons to reach that 8 electrons in the outer shell. So they're going to have an oxidation number of a -3. All right. I bet you can guess what the oxygen group is going to be. With 6 valence electrons, they want to gain 2, so they're going to have an oxidation number of -2. And for the halogens, 7 valence electrons, they want to gain 1 electron, so they're going to have a charge of -1. And then, of course, for the noble gases, they're already good. Their outer shells are already filled, so we don't even worry about the noble gases when we talk about oxidation numbers. All right? Let's move on to the metal atoms. Okay, so the non-metal atoms. So non-metals, remember, they're just the opposite of metals. Their outer energy levels are closer to being full. They're going to gain electrons, so they're going to have a negative charge. All right, and those negative ions are called anions. Again, you need to know that word. You need to know that an anion is a negatively charged ion. Okay, and the same thing with when you're writing the symbol for an ion, you're going to have the charge as a superscript. Okay, So that's metals versus nonmetals. Now, a new thing that we are going to have is called a polyatomic ion. Poly meaning many, atomic, of course, meaning atoms. So a polyatomic means many atoms, okay? And all that a polyatomic ion is a group of atoms that behave as a single ion. Oops, this right here is a typo. That should be single. So they act as a single ion that have a charge. So they can either be positive ions or they can be negative ions. All right. So we treat them just as a single charged ion. Okay. So here's a few examples. You got ammonium, which is NH4. It has a +1 charge. Hydroxide, you'll see that a lot. It is a negatively charged polyatomic ion. So it's OH with a -1 charge. Sulfate is a pretty common one. It is SO4 with a -2 charge. All right. I will be giving you a sheet that has a list of polyatomic ions that you will need to memorize. You'll need to know the name, the formula, and the charge. Okay. All right. Well, let's stop there for now, and the next time we will talk about how we name the compounds. Okay. Thanks.